Welcome back, ladies and gentlemen. It has been a while. If this is the first time you've checked in with the news, you'll see that I am, of course, in good condition. There was a bit of a, well, not really a scare, but a little concern. So I went and got tested, but I'm fine. This, of course, has meant that we've sort of been delayed in terms of getting through some of the video lessons, but at this point we are going to be able to at least continue with the new unit, which is kinematics. So, the notes on kinematics, or the introduction to kinematics, is incredibly short, at least compared to a lot of the other stuff we've talked about. If you take a look in your notes, which you should see online, it says here that the definition of kinematics is the study of motion that allows the predicting of the future or the past from the present. It further explains that kinematics is a way of inspecting the world, of breaking events into pieces, and then from those parts there's a set of equations that can describe the relationship that allows us to calculate a variety of variables. These are variables that we already know, that we've already used. The variables that we're going to be dealing with in the 5 different colors are going to be velocity, both final and velocity initial, acceleration, displacement, and time. These 5 variables are going to come up again and again and again. And our goal is to basically turn every question into one that involves these 5 variables. And what we're going to see is that so long as you have 3 of those variables, you can solve for the missing 2. You need 3 most of the time. We'll see a little later on in this particular unit that you can solve things when you've got more. But we just need our equations now. We need to understand what we're working with. Now, there are 5 equations in total, and you'll see them in the front page on page 2 of your booklet. And there's a little, your new booklet, there's a little chart here that breaks down all of the different equations and how you can use them. But I'm going to talk about them. The first equation is one that you know very well, or at least I hope so. A is equal to, we're going to pull out all the colors here. A is equal to Vf minus Vi divided by delta t. This equation should be familiar to you because this is the definition of acceleration, delta v over delta t. So there you go, already our first equation, and it's already one that we know. Equation 2 realistically isn't even a different equation. Equation 2 is what happens when you take this whole thing and you rearrange it. So Vf equals Vi plus A delta t. Now, the way we get that is that I multiply both sides by t, moving the t over, and then I just simply move the Vi over to the other side. So it's just a little bit of algebra, but there it is. And it gets used often enough that we basically write it as a separate formula. All right, so there's our first 2 formulas, and they literally come from the same place. Our third formula, I ended up showing a bunch of people throughout the course of the graphing conversion. And this particular formula is it's the equation for the area of a trapezoid, for those who remember when I explained that. For those who don't worry about it. It goes something like this. The displacement is equal to the velocity final plus the velocity initial. It is the only formula that does a plus there, just to mess with you. Normally it's minus. Divided by 2, all in brackets, and all of it's going to be multiplied by delta t. Now, there is a requirement for this. There is a requirement for this. This particular formula will only work if there is a single acceleration. So what that means is that if there's more than one possible acceleration, like for example, if we use a graph, right? If I put down here a graph, let's do a velocity time graph here. If I've got something that looks like, say, this, I can use that equation. But if I've got something that does something like this, and then I go, all right, I'm going to go from here, let's use a different color. I'm going to go from there to there, and I'm going to do this whole area all at once. It's not going to work. This will not work, this red line, because there are two different accelerations here. There's one going up and one going down, and this is assuming that there's only one acceleration. It's usually with something that people mess up. To be honest, equation 3 isn't that common. It's not used that often, not anywhere near as much as equation 4 and 5. Okay, so for equation 4, the way we get that is that we take 1 and 3 and we multiply them together. What do I mean by that? Well, here's 1, here's 3. So you'll see I've got these notes worked out. You guys can see them up online, of course. I'll make sure to put them there. But as it shows us here, right, we're going to have 1 multiplied by 3. Okay, so if I multiply 1 and 3, here's 1, here's 3. So I'm going to multiply A multiplied by delta D. Right, that's what I want to do in this context. I'll multiply those two together. Now, not only is that going to multiply A times D, but it's also going to multiply this times this. Okay, so we're going to have to write that out. So I'm going to get, let's go with VF minus VI, all divided by delta T. And that whole thing is, of course, the A from there. This delta D becomes the other part. And we're going to get VF plus VI divided by 2 all times delta T. Let's get a few brackets in there. Now, this, of course, looks terrible. Like, whoa, why would you do that, Mr. C? This part over here was pretty easy, and that's a little weird, but, I mean, they're not that complicated. Now you're making it super messy. This is normal in physics. So what's happening here is that we've got these two starting ideas, right? These two that I'm standing in front of. Very good, Mr. C. These two starting ideas. By taking those and putting them together, we can convert this particular starting equations into a new equation that we can use. It's powerful. Now, what ends up happening here is that we have to FOIL this, right? We're going to, like, multiply the first, multiply the second, all that kind of stuff. Once we finish doing that, we're going to get something that looks like this. A delta D equals, and once we use FOIL and we multiply it all out, we're going to get 1/2 from out here. I'm going to put it out front, and then we're going to get the times cancel because I got a time on the bottom and a time on the top. And then we're going to have to go like boom, boom. We're going to FOIL all of that stuff out. And when we do that, what we're going to get is VF squared minus VI squared. Now, this is basically the end, but usually we rewrite this in a new form just to make it a little easier to work with. And what we get when we finish doing that is we get VF, VI, both squared. Let's make that squared in black just to make it consistent. Plus 2 times A D. And that's equation 4. Now, that obviously looks way simpler than the stuff we did in order to get here. This is called a proof. This is sort of me showing you how we get from our starting conditions of these two equations to this ending condition. Now, proofs are sort of annoying, generally speaking. Not a lot of people really like them. People who really like math really like proofs. Proofs are basically me showing you that the stuff I tell you isn't just like true because I say it. It's true because I can show you that it makes sense. Now, the problem here is that there's a bunch of algebra, and we got to do a bunch of FOIL and a bunch of math, and not everyone's super comfortable with that. At the end of the day, do I expect you to memorize the proof? No, not even slightly. I expect you to know the equation. That's it. Okay, so there's our equation 4. So we've got 1, 2, 3, and here's 4. How do we do 5? Well, I'm running out of board space here, so I'm going to erase equation 4 and move it up a bit so we just get enough space. Oh, I got to rewrite all the colors again. Oh well, that's what the colors are for. The I, A, delta D, 2 plus squared squared equals. Incidentally, those squares, people are going to forget them. That's the number one problem with that equation, is everyone always forgets the square. And it's just natural, because none of the other equations have squares. So in order to get equation 4, I took 1 and 3 and multiplied them together. In order to get equation 5, I'm going to take 2 and 3 and add them together. Specifically, I'm going to substitute one into the other. This method is very common in very common in science and in mathematics, just like everywhere. So if I write that out to show you what I mean, I'm going to start with equation 3. So we're going to get delta D is going to be equal to VF and plus VI, all multiplied by time at the end there, and all divided by 2. Right? So this is my equation 3. So now what I'm going to do is I'm going to put equation 2 into equation 3, because this is one of those things that students tend to forget. The equal sign here doesn't mean that this is the answer to this. It means that these two things are the same. Right? So if I write, for example, 2 times 4 equals 8, I'm not telling you that the answer to the question 2 times 4 is 8. I'm telling you that 2 times 4 is the same as 8 in every way. So if I wanted to be super weird, I could write 48 as 42 times 4. Now, would I ever do that? No. But it's what it means. It means that 8 and 2 times 4 are exactly the same thing in every way. So this question here telling us that VF is the same as the rest of this stuff. So here I have a VF. I can erase that VF, and I can replace it with VI A T. Get some arrows in there. This has now replaced VF. Now, why would I do that? I've just made this more complicated. Because then I get to do some algebra, manipulate things, and I'm going to get something a little simpler. What I'm going to get, as it mentions here, is I'm going to get something that looks like this. I'm going to get delta D equals once again, I'm going to have to do a little bit of multiplication in here. And I'm going to get 2VI plus AT. All of that over 2. And finally, of course, there's a T on the outside. So again, all I've done is I've expanded this information, I've moved some of the V's around and stuff, just to make sure that it's all in there. Okay, so like for example, there's 2 VIs, right? There's 1 VI there, 1 VI there, so there's 2 of them. Anyway, let's keep going. Let's keep simplifying. Obviously, there's a 2 here and a 2 here. I can't just cancel them out because there's no 2 here. So instead, I'll get something that looks more like this. Delta D equals VI plus A delta T over 2. And all of that is going to be multiplied by a delta T. Right? This is the delta T from equation 3. So Okay, can we simplify this further? Yes, we just have to FOIL, we have to factor this in. So this one's going to times it by this, going to times over here. So when I do that, I'm going to get a delta t here, and there's 2 delta t, so I'm going to get delta t squared. And once I do that, I can get rid of these brackets, and that one's been factored in, and there we go. We now have our 5th equation. Now, obviously, equation 4 and equation 5 are a lot more complicated than 1 through 3. 1 through 3 are from the definitions. These equations are found by taking those definitions and assembling them together to figure out what's coming or how this all connects. So we now have our 5 equations. And what we're going to see is that when we're working with this stuff, again, you don't need to know how I got them. I mean, I just showed you them in order to be sort of more complete. But when we're working with this stuff, it's always going to be the same basic plan. You're going to find the 5 variables, you're going to list them. Then you're going to write down what information you already have. You're going to fill this chart in. Then you figure out which equation of the 5 is going to make it so you can solve the problem. Once you do that, you write out the equation, and then you solve it. Now, that's it. That's pretty much it for the notes. There isn't much else to do, so I'm going to immediately show you some examples. Because, yeah, all right, fine, I just showed you a bunch of math, and there's a whole bunch of algebra, and oh my dear goodness, algebra. Everyone always gets freaked out about algebra. If you guys flip to your booklets and you guys take a look at page 3 here, I'm going to do the first, let's say, first 2 questions. So let's erase this. All of my pretty colors, all gone. Oh well, can't win them all. So I erase all of the information, and I'm going to take a look at question 1. And what you're going to find is that when you're dealing with this stuff, it's all about understanding the question, breaking the problem down so you can solve it. So a skier starts down a slope that is 0.5 kilometers long with a velocity of 4 meters per second. If he accelerates at a constant rate of 2 meters per second squared, find the velocity at the bottom of the slope. So the first thing we have to do is fill in the information. We know that the acceleration is 2 meters per second squared. And it's down, so we'll say it's negative. We know that the initial velocity is negative 4 meters per second because he was going down the slope. We know that the slope itself is 0.5 kilometers. Now, these are both in meters. This is in kilometers. So I need to convert that, and it's going to be 500 meters. What is the velocity at the bottom of the slope? So this is what I'm looking for. VF, I don't know. I could also find time, and I might need to, but the question isn't asking for it. Okay, so now we have to figure out how to solve this. If you take a look at the little chart that I gave you on the first page, you will see that it shows you all the different equations, and it shows you roughly which variables appear in which equation. So for example, the very first equation does not have a d in it. Well, this question has a d in it right there. So if I try to use the first equation to answer this, this d is useless and doesn't help me in any way. I probably don't want that because I need at least 3 variables, and I've only got 3, vi, a, and d. So I need to find which equation has vi, a, and d, and also gives me the answer for vf. So for example, if I look at the vf column, the final equation here, it doesn't have a check mark in the vf column, which means it's telling me this equation can't find me vf. It finds me everything else, but not vf. Now, almost every equation does vf, so that makes things pretty easy. But only one equation will find me vf and give me d and use a. This one will find me d, but it requires t to do it because I don't have an a here. So of all the equations, this one here has all the variables that I have. So that's the equation that will make this the easiest to do. So my equation for this particular problem is going to be vf squared equals vi squared plus 2ad. I guess I should be a little less lazy. It's delta d. So here's my equation. Here's my variables. I start filling in the equation. We're going to get 4 squared plus 2 times a, which is the negative 2 there. And then the displacement, the displacement is downhill, so it's also negative, so negative 500. All of that will equal VF squared, which we don't know. So we got to get our trusty calculator, and we start plugging in our numbers. And we got to make sure we do this in the right order, right? This is an addition, so all of this has to be multiplied together first before I add it to the 4 squared. Well, 4 squared should be easy, right? 4 squared is going to be a nice 16. So we get here, this is 16, plus, well, 2 times 2 is going to be 4. 4 times 500, well, 5 times 4 would be 20. So we're going to get 20, and then I add 2 zeros. And then this, of course, negative and a negative becomes positive. The negative 4, should have put a negative there, becomes positive because I'm squaring it. So we're going to get a total of 216. Pretty sure. Let me just double check, make sure I didn't make any mistakes. Yep, looks good. Now, usually a student will get to this point and they'll go, all right, I must be done. You're not, because there's a square here. I want VF, not VF squared. So I'm going to square root both sides. So square root, where is that on this calculator? There it is. And I'm going to get that it should be about 44.9, 45. We'll say it's 45. So the final velocity here is 45 meters per second down. And there we go. That should be the answer. Now, like most of the problems that I'm going to give you, answers are in here. So we can take a look. The answers themselves are not on page 3. They're on page 5, and it says that it is 45 meters per second. So there we go. We managed to get it right. Notice the steps, right? Write out the information, put down the equation, solve the equation. You're going to want to do this. You're going to want to make this list, because right now we've only got a couple variables, but as we do more, we're going to get more and more variables to look at. Okay? So let's take a look at the next one, just because I want to give you guys one more to go off of. Obviously, what I should recommend right now, I've shown you the first one. You can try them from here on out. Maybe instead of immediately watching me do number 2, try number 2 yourself, and then if you're getting stuck, play the video in order to see it. But otherwise, I'm going to do number 2 here. So it says for number 2, pressing on the brake pedal slows a car from a velocity of 35 meters per second to 20 meters per second in 8 seconds. Assuming the acceleration is uniform, what is the displacement of the car? All right, so I'm going to erase all this stuff because I don't know what the answers are. I don't know if this is the equation I need. I don't really know anything yet. I've read the question. I don't know what I'm doing yet. The other Mr. C will tell his students, and I will recommend the same, read the question. That's step 1. Step 2, read the question again because you didn't read it right the first time. Step 3, read it one more time because you didn't read it right the first 2 times. Let's take a look at it again. Pressing on the brake pedal slows the car from a velocity of 35 to 20. There's no positives listed, so we can assume they must be positive. So it's not positive or negative, so we're going to assume it's positive. So this is 20, final, and this was 35, initial. It also says that we slow over 8 seconds. Finally, it tells us that there is an acceleration, but we don't know what it is. We just know it's a constant value. So we could calculate it, but we don't know what it is yet, and we're looking for D. So once again, we take a look at our list, and it says here that we are missing A. It's the only thing we don't have. Well, A is equation 3. Equation 3 is the only one that doesn't have A in it, so equation 3 will help us here. So a reminder, equation 3 is delta D equals VF plus VI over 2. It's the only one that's got a plus between these. Normally it's minus, times delta T. Okay, so we start filling things in. VF is going to be 20. VI is 35. Time is 8. All of that, of course, we add, is divide by 2 equals our delta D. Now let's get a green in there. Where did I put my green? Here it is. Delta D, there it is. So 20 plus 35 divided by 2 times 8. It's not necessarily an easy one to do in your head. So 35 plus 20 divided by 2 times 8, 280. and 20. Meters. And it'll be positive because it'll be forward. Once again, I can check my answer key. I take a look here, and it says 2.2 times 10 to the 2. Scientific notation. People taking chemistry might remember scientific notation. Hopefully some physicists remember it too. It says 2.2 times 10 to the 2 meters. What that means is that if I go 2 and I put a decimal here and I put a 2, it's telling me that there's a 2 here. So that means that I'm supposed to jump 2 spaces. So I go 1, 2, and then put the decimal, and then I fill in with zeros. 220, 220. That's how scientific notation works. A little reminder. Okay, there you go. You guys have got some examples. You guys can give these a try. We're going to be doing an awful lot of problems in this particular unit. So this unit, though the booklet is very thin, there is a lot of work in here. The first 20 questions, well, you don't quite have everything you need for the first 20 questions, but you probably have everything you need up until question, let's say 15. Everything you need to do up to question 15. Obviously, they get harder the longer you go. Question 10 with the physics turtle is especially challenging. I would be curious to see how many people can put that one together. It's not the hardest question in this booklet, not by a long shot, but it's still pretty challenging, especially for the 10th questions you're going to try. But give it a try, and of course, I will be here to help, and I will see you guys next time.